Welcome to EDU World Space.
So we're asked to find the tension of this DE cable here, given that the tension in the AB cable is 306 pounds. And I've already found the position vectors of the 4 different points on the figure. And to start with, I'm going to first find the AC vector. So the AC vector, we can do C vector minus A vector, and this will give us negative 1i minus 12j plus 12k. And we're also going to find its magnitude, which will be negative 1 squared plus negative 12 squared plus 12 squared, all under the square root, which will give us a value of 17 feet. Next, I'm going to find the dF vector. So the dF vector, this will be equal to the F vector minus the D vector. And this will give us 1.5i minus 14j plus 12k. And its magnitude will be 1.5 squared minus 14 plus negative 14 squared plus 12 squared all under the square root. And this will give us a value of 18.5 feet. Next, I'm going to write out the formula for the tension on the AB cable or the AC cable. So I'll write it as the tension vector of the AC cable. This will be equal to the magnitude of the tension times the AC vector divided by its magnitude. And plugging in what we know. So we're given this tension we're given, and we've calculated the AC vector and its magnitude. So now we just plug in. So we have 306 times the AC vector divided by its magnitude. And next I'm going to write out the formula for the tension on the DF cable. So the tension vector on the DF cable, I'll write it as the magnitude of the tension on the DE cable times the DF vector, this DF vector, divided by its magnitude. And plug in what we know. Set this equal to the magnitude of the tension times 1.5i minus 12j plus 12k divided by 18.5. And next I'm going to write out the formula for the sum of all x components of the moment. So the sum of all x components of the moment is equal to the tension, the Z component of the tension on the AC cable times, all right, like this. So times the Y component of the A position plus tension, the Z component of the tension of the DF cable times the Y component of the D position vector. And we plug in what we know. So this sum is given by the problem. And we can get the Y components from the figure. And we can also get the Z components from what we just calculated. So I'll start off with the sum. So this sum of moment of the X component, write that as 4728 is equal to this Z component. So this Z component, we go back to our formula for tension vector for our AC cable. And we can get the Z component by doing 306 times the K component, 306 times 12 divided by 17. And that will give us our Z component. And that number will be 216. Then we multiply by the Y component of the A position, which is 12. And then the Z component of the DF vector. So we go to our equation for the DF vector, and we do this tension magnitude times the K component divided by 18.5. So that's going to look like, this. So 12 times the magnitude of the tension divided by 18.5. And then times the Y component of the D position vector, which was 14. And now we take this equation here and we solve for this unknown value. Solve for this unknown value. So after doing algebra and solving for that value, we get the magnitude of this tension to be equal to 235.214 pounds.